Hello everyone, welcome back to my channel. So today I have come with a new video in physics and the name of the topic motion in one dimension. So as promised in my earlier video that I will be at first telling or completing velocity time graph and acceleration time graph. So I will be doing that at first and then I'll proceed with graphical derivation of the three formula. By definition I have already derived it in one of my previous video of this particular chapter only, and today we are going to derive it graphically. Before that, let us at first know velocity time graph and acceleration time graph. It will hardly take time and then I'll proceed with the graphical derivation. So at first, acceleration time graph. It is not so important, though it's important, but most of the questions for 9 and 10 comes from, not 9 and 10, for 9 comes from velocity time graph and displacement time graph. Displacement time graph I have already explained in a elaborate manner in my previous video, and I have given a touch of VT and acceleration, that is AT time graphs, in that particular video only. Today I am going to say rest of the parts and get it over. So acceleration, as told in my previous video, it will always be the y-axis and x-axis remains fixed with time. So it's your time axis. So first of all, what is slope area? I have already told you in my previous video, so not telling you again. Slope of acceleration time graph will not give you anything because acceleration by time has no value. So slope cannot be found. What can be found is your area. So if you are finding out the area of acceleration time graph, I am writing in short A into T. That is y-axis into x-axis. Now here I am writing y-axis into x-axis, but normally you cannot write. Like suppose I have already drawn here, again I am drawing. If your graph is like this, you have to join this like with the dotted lines. It forms what? A rectangle, so you have to use length into breadth. If suppose your graph is like this, then what does it form? It is forming a triangle, so you have to use half into base into height. So you have to judge which geometrical figure it is, and accordingly you have to apply the formula of its area. But make sure you do not directly multiply y-axis with x-axis. But since here these are the way how you will apply. But what is the concept? That is y-axis into x-axis. You are ultimately multiplying both the axes, but not directly, but using the formula of areas. Like this, if you do, it will be correct. But if you do like this, totally wrong. But to explain you the idea of this, that's why I am using A into T. That is y-axis into x-axis. But during examination or anywhere like this, it cannot be written. So acceleration into time gives you what? Velocity. But slope is what? Acceleration by time. Will it give you anything? No. It is not going to give you anything. Now, what is this graph basically? This is a graph of acceleration time graph for a free falling body. Okay. For a free falling body. What is free fall? Suppose this is your earth and a body is falling towards earth. So with each second, suppose it is initially having a velocity x, with each second 9.8 meter per second will be added to its initial velocity. 9.8 meter per second will be added to its initial velocity. So here it is having 9x plus 9.8. Again here, that is your first interval. In your second interval again x plus 9.8 again plus 9.8. Like this again it will be added. Again in your third interval again another 9.8 will be added. Obviously 9.8 meter per second, that is it will be added in your velocity. Okay. That means what does it prove or what does it imply? That is acceleration is 9.8 meter per second squared. Because this is the rate of change of velocity, 9.8 meter per second squared, right? So 9.8 meter per second squared is your acceleration. Now here I have rounded off to 10. Okay, this can be rounded off to 10 meter per second square. So here also I've used the SI unit 10 meter per second square, and here only second. So in the first second, see, that is having now, it is uniform acceleration. Is it changing? Suppose in first second it's 10 meter per second square. In the second interval it is 30 meter per second square. Not like that. With each second, the acceleration remains constant. That is 9.8 rounded off to 10. So, constant acceleration. With each second, acceleration is not changing. So this is the graph of acceleration time graph for a free falling body. Now coming to velocity time graph, same concept, nothing new. Velocity time. Meter per second second. So two things you have to know, slope and area of this particular graph. So what is the area giving us? Again same way, you have to judge which geometrical figure the graph is forming. According to that, you have to apply the formula of its area. But initially we are multiplying both the axes. Y-axis, x-axis. So velocity into time is giving us your displacement. Okay? And if you are finding out the slope, it's y-axis by x-axis, not directly. Suppose here it's 10 and here it's 2. Okay. So something the graph, if the graph is somehow like this, then you cannot do directly 10 by 2. Because just because I have told slope is y-axis by x-axis. No. For this also there is a way. Answer will be same. But for this also there is a way. So for that, do check out my previous video. There I have explained you. So directly you cannot divide. There is a way of dividing. Answer may be the same, but the way, the process is incorrect. So here you are doing y-axis by x-axis, velocity by time. What is giving? So velocity by time is what? Acceleration. Now for a free falling body, the acceleration is changing by 9.8 meter per second with each second. It is increasing, right? So again I am doing one thing. I am drawing another graph over here. This is the velocity, time axis. So 0. So again I have rounded 9.8 to 10. So the graph is like this. Okay. So in the first interval increased by 10. Second interval again increased by 10. So 10 becomes 20. 20 becomes 30. Like this it is increasing, right? So velocity time graph is like this. Okay. So that was all for your velocity time graph and acceleration time graph. Now let's proceed with graphical derivation of the three formulae. I'll show you the graph as well as I'll show you the three formulae. Okay. Number 1, v equals to u plus at. Number 2, s equals to ut plus half at square. Number 3, v square equals to u square plus 2as. Now first of all, how will the graph look like? Okay. So you have to make one thing clear or one thing sure, that the graph that you are going to use is a velocity time graph. So this is your velocity time graph. Okay. Now the graph will be like this. What does this graph imply? That is, the body whose velocity has been plotted on this graph was initially having a velocity. If it would have started from rest, we could have started from the point of origin. This particular point where the y-axis and the x-axis intersect, this point is called point of origin. point of origin always have the value 0. So if we could have started the graph from the point of origin, that means we are starting from 0, which will imply or which would have implied that the body is starting from rest. Initially the velocity is 0. But here it is already having some value. So initially the velocity is not 0. It is having some value. It is already in motion. It is having velocity. And with time it is increasing. Okay. Now instead of giving some value, what we will do is we will denote it by u. Okay. And this particular point till which it has reached, this will be marked as v. Why? This was the initial velocity. It has reached to this point. This is your final velocity. Okay. Now the time it has taken to reach this final velocity, let it be t. This part is clear. Now we will just name all the points. Let this point be A, this point be B, this point C, this point D, this point E. Okay. And we will do one more thing, that is we will join this portion. Okay. Like this. And we are naming this point as F. So let this be. So this was your A. So let me do one thing. Let me increase the size. Okay. Too small. Maybe it's not visible to you. Now I hope it's clear and visible. Again, this is a graph remains the same, just I have rubbed it to increase its size to make it more clear in the video. So this is your initial velocity. This is your final velocity v, and the time taken is denoted by t. And we are just naming all the points and we are joining this portion, and this portion A, B, C, D. This portion E, let this portion be F. Okay. So this point A, this particular point is A. This is B, C, D, E, F. Done. And what is this? Velocity time graph. First of all, let us find v equals to u plus at from this graph. We will find this from this graph. How to find? Now, from where does this formula come? This has come from a equals to v minus u by t. That is, it has come from the formula of acceleration. So, do you think acceleration is possible from this graph? Just now in the starting I have explained. Yes, it is possible. Why? Because if you are finding the slope of this graph, what we will be doing? Velocity by time. What will it give us? It will give us our acceleration. So if we are finding acceleration, easily we can form this formula. Done. Just take it simple. Velocity time graph. First formula deals with acceleration. If we are finding out the slope of this particular graph, easily we can find acceleration. From acceleration we can find out our first formula for this chapter, that is v equals to u plus at. So let's do it. So what we'll do is we'll find out the slope. Now slope cannot be easily done. If you have watched my previous video, there I have said we cannot do directly. We are taking the final value, right? We cannot do v by t directly. No, it is not possible. What we can do? We have to take one upper value and we have to take one lower value. Okay, we have to take one upper value and we have to take one lower value. What is your upper value over here? Your final velocity. And what is your lower value over here? That is your initial velocity. So v and u. So before that, one thing you have to be clear with, that is directly rather than writing like this, let us be more appropriate. Let us be more to the point. First of all, we are finding the slope of this portion, right? This portion we are finding the slope. This. So what is this? E and D. ED. Done. Then this was your y-axis. Now finding out the value on the x-axis. So this particular point from A to D, this will be your value on the x-axis. So this is your AD. So ED by AD. Simple. Now, can we do like this? ED is equal to FA. This particular length is also this particular length is also equal to this particular length. So ED is also equal to F and A. So can we write ED equals to FA? Yes, obviously we can write. Now AD, this point, this particular line is also equal to BC, this line, right? So we can write FA by BC. Now what is FA? Now directly we cannot write FA, right? I have told you we have to subtract from the upper value to, means upper value minus lower value. We have to subtract. Directly we cannot divide. Though the answer will come the same, but still we have to show it in that manner. That's a way of showing this, or that's a way of finding the value. For more vivid idea of this or clear idea, you will go through my previous video. So it is your V minus U. Now what is your BC? BC is what? T. This particular length, it is what? T. Why? Because this was your 0. Upper value T, lower value 0. What is T minus 0? Obviously T. If T is 2, not 2, suppose T is 10, 10 minus 0 will be what? 10. So T minus 0 will be T. So directly writing over here T. Okay? Now, this is what we have got. V minus U by T. So half of the work is done. Now slope of velocity by time is giving us what? It is giving us our acceleration. And what we have got? V minus U by T. Acceleration can be abbreviated as A. So A equals to V minus U by T. Now simple. AT equals to V minus U, cross multiplying and sending U this side. So AT plus U equals to V. So changing the sides, V equals to U plus AT. First formula derived. Simple. Now deriving the second formula. Second formula is easy, but there you need to do one thing, that is you have to be much more conscious while finding out second and third, because there very complicated, not complicated, I should not say complicated, but very minute concepts have to be applied. Okay, so for that you have to be much more careful. Just listen to me carefully. Now if you want to find out the second formula is what? At first let me make you note that S equals to U plus AT. Right? Now what we'll be doing is, what is given over here? S equals to U plus half AT square. Right? What is S? S is displacement or distance, but here since I have taken velocity, so I am writing displacement. As already told in the beginning of my video, how can displacement be found from a velocity time graph? By finding out the area. So we have to find the area. Now we have to judge the geometrical figure. That I will show you how to find. But before that, just make this particular concept clear. That is to find out distance or displacement from velocity times, we have to find out the area. Here what we are finding? We are finding displacement only. We forget this part. Forget. Just remember what we are finding. We are finding displacement. How can it be found? By finding the area. So simply let us proceed by finding the area. Then we will see what happens. So, area. The area of what? We have to judge the geometrical figure. Can you see this particular thing? Forget this part. What is it looking like? Isn't it looking like a trapezium? A, E, C, B. Isn't looking like a trapezium? Yes, it is. So what is the geometrical figure? It's a trapezium. In the starting only, let me tell you the area of formula of trapezium. Finding out the area of trapezium, we can apply half into sum of parallel sides into distance between the parallel sides. Done. This is your formula. So area is what? Area of trapezium. Now directly you will not be able to find out the area of trapezium. For that let us break this particular figure into two parts. Again I am joining. So you can see AED is a triangle. This is a triangle. This is a rectangle. So this particular trapezium, it was looking like this, and now we are breaking it into two different geometrical figures. And the formula we are applying for triangle, we will apply half into base into height. For rectangle, what we will apply? Length into breadth. Done. So now, let us write like this. What is the area giving us? It is giving us our displacement. Displacement can be abbreviated and written as S. S equals to area of this triangle plus, what is a triangle? Let me write the name also. AED plus area of rectangle. What is the area of rectangle over here? Means what is the name of the rectangle? ABCD. So rectangle ABCD. Simply now we will find out the area. Simply. So we have to forget this particular formula. Okay? Just to make you know I have written, but we have to forget this formula. So we no longer need the formula of area for trapezium, since we are using formula of triangle and rectangle. Done. First finding out the area of triangle. This is your triangle. Half into base into height. Half. What is your base? Base is what? AD. This is your base, AD. Into base into height. Height is what? ED or DE. I am writing ED. Names may not match with the book because I have named it according to me. Okay, in every book you have different namings. Here I have given the name as per my convenience. Okay. So half into AD into ED. That's half into base into height. Done. Let's close the brackets. Area of rectangle. Length into breadth. What is your length? AD or BC? Let's take BC. Breadth. What is your breadth? DC. Okay. Now, what we will be doing is we will just replace. How we will be replacing? Half into. Now, what is your AD? See, AD is this thing, right? AD is this. Now AD, can you find similarity with BC? Yes, obviously it is very easy. This is your AD, similar with BC. AD, similar with BC. BC is what? T. Again I am telling. AD equals to BC. BC is what? T. Right? Because it's clearly written over here. T. Hope it's visible. Okay? Time axis T. So AD can be replaced by T into. This is your ED. This is your ED, right? ED, can you find similarity with FA? This is your FA. This is your FA. Similarity can be found. This point is FA. And what is FA? V minus U, right? One second. Yes. FA is V minus U. Closing the bracket. Plus. Now, BC. BC is what? This. Right? Again, it can be replaced by T. What is your DC? DC is what? U. This is your DC. DC is similar with AB. AB is similar with U. I'm going very slow. Now, we know V equals to U plus AB. Right? We know this, which implies, or you can write like this also, which implies V minus U equals to AT. Okay? Again I am writing the formulae. Okay? Half into T. What is V minus U? V minus U is AT into AT. Done? Plus T into U can be written as UT. Already towards the end of this particular derivation. All this is S. Now T into AT is what? AT square. So half AT square plus UT, or which further change of sides or change of places, half UT plus half AT square. Finally, second formula derived. Done. Coming to third formula of motion. That is V square equals to U square plus 2AS. Now it's also simple. Just we have to apply, different concept. Concept is same. I should not say different concept, but little bit more complicated. Okay. Hope it was not so tough for you. First one was very easy. This was also not creating a problem for you, because this I've tried my best to explain the most easy way or the easiest way. Okay. Now for the third formula, simply we will apply the formula for this thing, trapezium. Half into sum of the parallel sides into distance between the parallel sides. Now here also we are finding V square, right? So here also we will find the distance. Here also we will find the distance, that is S. Clear? So means the area only we are finding. We are finding a distance, displacement, we are finding the area. Simple. So S equals to area of trapezium. What is area of trapezium? Half into sum of the parallel sides into distance between the parallel sides. So half into sum of the parallel sides. Now this is your parallel sides. This is another parallel side, right? First parallel side AB. Second parallel side EC. So we are adding these two in the distance between the parallel sides. This is the distance, that is AD or BC. Chala, I am choosing AD. Again S equals to. What is AB? This is your AB. AB is what? U. AB, this particular thing is what? U. EC. This is your EC. This whole line, this whole thing EC. What is EC? EC is what? V. So we will just simply write V. What is AD? This is your AD. Right? AD is equal to BC and BC is equal to T. Again repeating. AD equal to BC. BC again equal to T. So plus T. Done. Now we know V equals to U plus AT, right? And T equals to V minus U by A, right? V equals to U plus AT, T equals to V minus U by A. So can we replace T from this particular equation? Yes, we can. So half into U plus V plus, into, this already be into V minus U by T, that is equals to, this all are your S, that is equal to half into U plus V, or you can write in this way also. Let me directly multiply in this line. So I'm showing in a more broader way. U we are multiplying with both the values, so UV minus U square, again we are multiplying, plus V square into minus VU whole by T. Done. So S equals to half into this V U minus UV plus UV gets cancelled. So by T. Okay. Now simplify it and write it in this way. That is V square minus U square by 2T. This can be written in this way. Acha, one mistake I have done, that is V minus U by A. Here I have replaced by T. Okay, that's why it wasn't matching. So VA. Simple mistake. Just rectify it once. Okay. So A. Instead of T, here I have written correctly. It will be A. Just I have copied it wrong. So it will be V minus U by A. So simply we are doing it. Now multiplying, cross multiplying, 2AS equals to V square plus U square. Done. Changing the sides. V square equals to 2AS. One thing. Okay. Just changing the sides. That is 2A multiplying with S. So 2AS equals to V square minus U square. So V square, just then transferring U minus U square this side. So V square equals to U square plus 2S. So this was all for today's video. With this we have completed with our motion in one dimension. In my next video I will be coming with a new chapter. The most interesting chapter, that is laws of motion. First part of laws of motion deals with types of forces, whose video is already made previously 1 year ago. So I will be directly starting with Newton's laws of motion. So till then, thank you. Hope you have liked my video. If you like my video, please like, share and subscribe it. Also press the bell icon to get the notification of my uploaded video. So till the next video, stay safe. Okay, bye.